This is pre-calculus. Hints about project for the third marking period on Sine. All right. Question 1. On graph paper, draw an acute angle theta in standard position. All right, I'm going to teach you what standard position means in section 6.3, but you haven't gotten there yet. So a little bit about standard position and doing step 1, drawing your angle. The initial ray for any angle in standard position has an endpoint at the origin and a ray that goes on the positive x-axis. So that is the initial ray of an angle that is in standard position. Okay? An angle in standard position rotates counterclockwise from that initial ray. And if it's acute, that means it has to be less than 90 degrees. That means that it can't go past the y-axis. All right? So the second ray, what we call the terminal ray, has to be in quadrant 1 in order to meet these qualifications. So here I have an acute angle theta. Now, hopefully we will have a variety of thetas in this classroom. Nobody's angle is going to be the same as anybody else's angle, okay? And one of the things that we should see by looking at this project is that we're going to get some similar results regardless of what the angle is. Okay, so that's step 1. Step 2, draw 3 concentric circles centered at the origin. All right, so if you remember from geometry, concentric means circles that have the same center, okay? And here we've got, oh, this protractor is very wiggly. All right, I'm going to pause, hold on. All right, I am back, and that's a little tip there. Some of these tools are not in good shape, so we want a stiff compass that the pencil isn't going to slip in and that the value isn't going to change. All right, concentric circles all have the same center, and here it's telling you that the center has to be on the origin. They have to be 3 different concentric circles with the same center. Okay, so, oops. All right, so when I'm drawing a circle, I've got the pointy end on the origin, and sometimes it's easier, instead of moving the compass, move the paper. Okay, there's circle 1. It's not going to be real dark. If you're pressing down real hard, then your compass is going to move. All right, here's my circle 2. Okay, circle 3. Okay, I did a really nice job there. All right. Step 2, draw 3 concentric circles centered at the origin. Mark 3 points P1, P2, P3 where the circles intersect the terminal ray of theta. So this ray here is the terminal ray. So my first intersection with the terminal ray and the first circle is P1. The second intersection is P2. The third intersection is P3. Step 4. Oh, in step 3, carefully measure the radii. Okay, so it really doesn't matter which ray you measure the radii on. Okay, but and they're asking you to do this in centimeters. Okay, so let's do it on this ray because it's okay. So my radii are at 2.3, My second radii, my R2 is at 4.8. My third radii is at 7.2. Okay, so that's how you measure the radii. Radii is plural for radius. Okay. All right, step 4 is to drop down 4 vertical lines. I hope you know what vertical means. Okay. Vertical are going to be perpendicular to the x-axis. All right, and they should be dropping down from P1, P2, and P3. Okay. And you're going to measure each of those in centimeters. So that looks like it's about 2. Yours had better be different, okay? I'm just showing you how to measure, but your circles should be different, your angles should be different, etc. All right. This one looks like it's about 4.3. This one looks like it's about 6.2. Okay. Step 5 is to write the ratios. I didn't write down, okay, my measurements, but you are going to put your y1 divided by your r1 and round to the nearest hundredth. Your y2 divided by your r2, your y3 divided by your r3. All right, use a calculator to find sine of, 6, use a protractor to measure the angle of theta. When you're using a protractor, this little dot has to be at the origin because that's the vertex of the angle. This line that represents where 0 is should be at your x-axis, right? And you're going to line up your terminal side to get the measure. Now, I lucked out quite a bit here because this is as perfect a 60-degree angle as I can imagine, all right? So theta equals 60. I hope yours doesn't equal 60. All right, 59, 58, 72, I don't know. Okay, please don't make yours the same as mine. All right, so now use a calculator to find the sine of theta. This is step 7. All right, that's too dark for you to see. Okay. All right, so I've got it. Make sure that you are in degree mode and do sine of 60. You're going to do sine of your theta, not mine. All right, so round to the nearest hundredth. This is 0.87. 0.87. Rounded to the nearest hundredth. Problem 8 is to calculate, or not calculate, to compare 5 and 7. Well, you know what to compare means, I hope. Are they the same, or are they close, or are they different? How much different? Why? Okay, so you're going to be writing a sentence or two for problem 8.